consider the function y equals 2x over x minus 4. Okay, so I think we've sufficiently considered it, so let's talk about it. Complete the table and sketch the graph. Well, that's the right order, right? We've got to complete the table before we can sketch the graph. So you all have your calculators on your desk, yes? So go ahead and put that equation into your calculator. Now, some of it we don't need our calculator for, do we? What if it's 1? What's 2 times 1? 2. What's 1 minus 4? Negative 3. So I have 2 over negative 3. So negative 2/3, right? What if it's a 2? What's 2 times 2? 4. And what's 2 minus 4? So 4 over negative 2? Negative 2, right? What if it's a 3? What's 2 times 3? 6. What's 3 minus 4? Negative 1. 6 divided by negative 1? Negative 6. What if it's 4? It's 2 times 4? 8. What's 4 minus 4? Are we allowed to divide by 0? Who's the only person that we know of that can divide by 0? Chuck Norris, and he's not in this class, right? So we can't, that's not something we can do. Okay, so let's skip that one for now and go to 5. What's 2 times 5? 10. What is 5 minus 4? So 10 over 1? 10. What about 6? 2 times 6? 12. 6 minus 4? 2. So 12 over 2? 6. 2 times 7? 14. And then 7 minus 4? So 14 over 3? So like 4 2/3. Can we write that? Yeah? So this is a problem, right? So instead of just going straight to 4, let's go right before 4 and let's go right after 4. Okay? This is where it might be simpler to use our calculator, right? So I'm just going to go, I'm not even going to go to a graph, I'm just going to go to a calculate page. Make a new document that is a calculate page, calculator. Okay? And I'm going to say, I'm going to make myself a fraction. Well, not my personal self, but in the calculator, and say 2 times 3.5 over 3.5 minus 4. Because that's what it's asking me to do, right? 2 times x and then x minus 4. Negative 14. Okay, I just did 3.5. Somebody else do 3.8. Somebody else do 3.9. Somebody else do 4.1, 4.2, and 4.5. When you get it, tell me which x value you had and tell me what you got for your y value. Which one did you do? 3.8? Negative 38. Okay. 4.5 is 18. Thank you. .1 is 82. Okay, somebody different? .2 is 42. Okay. And what about 3.9? Negative 78. Thank you very much. Okay. Now, guys, there was a lot of hesitation in the beginning, right? And from what I saw, at least one person in here did it twice. The one that they chose, they did it twice because they didn't think it was right. Is that a logical thought at this point? It is, right? Because we're working with numbers like negative 2/3, negative 2, negative 6, 10, 6, 4 2/3, and suddenly we have 82. Now, is 82 a big number? No. I mean, if I owe somebody $82, that's a big number, right? Okay. But if we're talking about distance between here and the moon, 82 miles is not even that far, is it? Okay. So keep in mind that sometimes crazy numbers can happen like this, especially around asymptotes. Okay. So just keep that in mind. So let's graph this so we can kind of get a picture of what's happening. So if x is 1, y is negative 2/3. If x is 2, y is negative 2. x is 3, y is negative 6. Okay. We're not going to graph 4 yet. I'll come back and graph these in a sec. Well, I can't even graph those, can I? It only goes to 10 and 6 and a negative 6. I can't even graph any of those, can I? Okay, we'll talk about that in a minute. 5 is 10. 6 is 6. And 7 is 4 and almost 5. Okay, so earlier when we did this part, somebody said, God bless you, somebody said, that doesn't even look like anything. And you know what I said? You're right. It doesn't look like anything we've done before, does it? Okay? I mean, if we connect and connect and connect, this just doesn't seem right, does it? Okay? So, I know it's a function, right? I know it's a function like this so I can connect it, but I don't want to yet. All right, let's talk about this. As we're going this way toward 4, what's going to happen if I graph these three things right here? If I graph 3.5, where do I have to go? Down 14. So maybe like right here. And then if I graph 3.8, I got to go down 38, like down here somewhere, right? And if I get a little bit closer to 4, I got to go down even further, don't I? So I could go ahead and graph something that looked like that, knowing it's going to keep on going. And chances are I also know it's going to keep on going this way, don't I? What about this side right here? What do I know? Well, if I started right barely on this side of 4, at 4.1, it's 82. It's way up here, isn't it? If I went just a little bit further, it's still way up here, but maybe not as far. And if I have 4.5, it's like here or something, right? So I know it's coming from up there to go that way. Does that remind you of anything we did at the beginning of the year? I know it's been a couple months since then, so if you don't remember, that's okay. It kind of looks like exponential, but there's two parts. What form is the equation in? It's a fraction, isn't it? We did talk about a kind of function that is a fraction, and we called it rational function. Do you remember that? Okay. So we're talking about rational functions right now. Okay? But here's the deal. What happens if I put 4 into this? If I put 4 right here, what do I get? 8 over 0. Is that allowed? No. When that happens, that is where my asymptote lives. Right there at 4. Could I look at this equation right here and know automatically that at 4 is where my asymptote is? Yeah, you could, right? How could I look at just the denominator? I'm already giving you the hint, okay? How could I look at just the denominator and know that it was 4? It equals 0, right? So if I'm trying to figure out where the asymptote is, even in my head, I can do it sometimes, right? We could do that in our head, right? To find my vertical asymptotes, what I have to do is set the denominator equal to 0. Now I'm purposely setting the denominator equal to 0 to figure out what x is not allowed to be. By solving for x, that tells me what x is not allowed to be. Does that make sense? A little bit? Okay. Why did I go ahead and draw it then? If nothing's allowed to be there, why did I draw it? So we can see it, right? We're visual people. A lot of us are much more visual than others, but this gives me a visual reminder of where that asymptote is. And I know that this is going to go up and up and up, and is it ever going to get to 4? No. I know this is going to go down, down, down as it's moving to the right. Is it ever going to get to 4? No, it's not. Because 4 is where my asymptote is. And I know that because I can set my denominator equal to 0. Okay? This is a funny question to me. What kind of asymptote is this? I'm like, did they even look at the title of the worksheet? But that's okay. What kind of asymptote is it? Vertical. Guys, why did I draw the asymptote with a dotted line? Because there's not an actual thing there, right? If I drew a solid line, that would be implying that there's a line there, okay? But I drew it as a dotted line to remind myself that nothing is there, but I'm going to pretend this asymptote is there so I know that nothing is there. Yes? So here's what they want us to do, okay? They want us to go every single one of these tables. They want us to plug in all these values and fill this out and then figure out where the vertical asymptote is. This is what I was telling you before. Yes, we could discover this, but we already know that we can set the denominator equal to 0. So can we kind of go through this kind of quickly? Is that okay with you? Like without even filling in the tables, are you okay with that? So tell me where the vertical asymptote is here. Okay, so now we have to argue. Okay? Because, what is this again? It's a vertical asymptote, and we draw it as a line, right? When you come in here and I need your help sometimes, do I say, hey girl, get over here and help me? Even if I was being polite, would I say, girl, would you please come over here? No, because that's what, 8 of you? Nobody knows what I'm talking about. Do I say, boy, come and help me take the things off the wall in the hall? No. I mean, everybody knows who I'm talking about, but we don't say that, do we? Forgot to take them down, did you? Okay. We don't say that way because that's not clear who we're talking to. If I need Sean's help, I say, Sean, would you please come and help me? If I need Allison's help, I say, Allison, please come and help me, right? Because that specifically identifies exactly who I'm talking to. For that same reason, I can't just say 2. Because how many lines on a graph could be represented by 2? For sure 2, right? Maybe even more than that. So I need to be very clear in how I call my vertical asymptote. How do I name a line that looks like this? X equals 4, right? So how am I going to name this vertical asymptote right here? X equals 2. Very good. Now do you see why I needed to argue with you? Because here's the deal. If you just put 2, that's wrong. Okay? Because 2 is just a number. It's not an equation of an asymptote. Look at number 2. Where's the vertical asymptote? X equals 6. What about number 3? Very good. X equals -3. What about number 4? Ooh, that one's harder. Oh, okay. Sorry. X equals 6, right? That's still something we can do in our head, isn't it? Okay. What about this one? Can we do this in our head? Yeah. Negative. I almost wrote this. That's why I hesitated. -3/2. Same thing, right? Okay, some people like fractions. Most of you don't, but that's okay. I just wanted to write it. What about this one? So what if we get to this and some of us can't do this very easily in our heads? What are we actually doing? We're setting denominator equal to 0. So what if I actually wrote this? 0.5x plus 2 equals 0. If I subtract 2 from both sides, I get 0.5x equals -2. If I divide both sides by 0.5, I get x equals -4. And by solving that and setting it to 0, now I know exactly where my vertical asymptote is. Does that help? Okay, I want you to be very careful with this one. What? Oh, thank you. Thank you. No, thank you very much. I want you to be very careful with number 7. That's what I was afraid you would say. It's okay. Somebody had to say it though, right? So thank you for saying it. If we set it equal to 0 and add 4 and add 4, I get x squared equals 4. How do I solve for x? Who put the square root in the problem? So what do we have to remember? So how many asymptotes does this have? 2. And because we're good, compliant math students, we're going to write them as two separate lines, not just x equals plus or minus 2. Okay? Each of them are separate lines, so we're going to write them as separate lines. Does that make sense? So how do you find a vertical asymptote? Set the denominator equal to 0, right? So let me ask you another question. How do you find a vertical asymptote? Set the denominator equal to 0. One more time. How do you find a vertical asymptote? Set the denominator equal to 0. Okay? Please circle the following questions on the back. 1, 2, 4, and 8. Okay? 1, 2, 4, and 8. That's what I want you to do for homework on that worksheet. Okay? Now I need to talk to my basketball players. Do I have any in here? You think so? Okay, we'll pretend there's some basketball. Has anyone ever heard of basketball before? No? Okay, well, I guess we're out of luck. I'll just try to talk and explain the game as we go. How about that? Okay? So, when you play basketball, you have a basketball. It's a ball that you throw in a basket. That's why they call it basketball. Okay? But Charlie she's a basketball player. Okay? But so far this season, she's attempted 30 shots, and she's only made 13. So for the record, that's not great, is it? Okay? It's not great, but she's trying, right? So up to now, what is her stat for her statistics for the percentage of free throws made? Well, how do you find a stat for percentage of free throws made? You take what she's attempted and divide by what? How many she's tried, which is a 3, not a 2, Kingston. What is 13 divided by 30? $13 divided by 30 is not impossible. 0.433? Well, if that's the decimal, how do we find the percent? What do we multiply it by? 100, right? So 0.433 times 100 is what? 43.3%. If you were on the basketball team, how do you think coach would feel about 43% free throw shooting? Not great, right? Not great at all. So after such a poor start, she gets some advice from her coaches and practices daily. If she does not miss another free throw for the remainder of the season, I'm going to ask a question, but I don't want you to answer it out loud yet. Okay? How many consecutive free throws will she need to make before her percentage reaches 80, 90, and 100%? So let's see if we can figure it out. So I need somebody to do the right now one. Who's going to do right now? Raise your hand. Sean, you got that one? Who's going to do 1? KK, who's doing 2? Thank you. Who's doing 3? Allison does that. Sophia, would you do 4? Who's doing 5? Dimitri has 5. What about 10? Thank you. Who's doing 20? Clay, you got 20? Who's got 50? Thank you, Ethan. What about 100? Thank you. Excuse me. Who had right now? Who volunteered for right now? Sean. Okay, so Sean, your fraction is 13 over 30. What is your decimal? 0.433. And what is your percent? 43.3%. Okay. Who had 1? KK. Why did yours go from 13 over 30 to 14 over 31? So she made another one and she attempted another one. So it was increased by 1, right? What is your decimal, KK? 452. And what's your percent? 45.2%. Okay. Who had 2? Thank you. Would you give me your fraction, please? 15 over 32 is correct. What's your decimal? 469. We'll do 469. That's fine. And what about your percent? Very good. What about who had 3? Okay, would you tell me what your fraction was? Very good. And your decimal? And your percent? Very good. What about 4? Very good. So 5%? Is that what you said? Oh, 50%. Okay, I was like, we have to talk. No, that's fine. That's fine. Okay, who had 5? Would you tell me what your fraction is? Okay, good. Very good. Excellent. Who had 10? And what was your fraction? Yeah, 23 over 40, right? Okay. So it's 10 more than what we started with, right? Each one of these is 10 more than what we started with. So what's your decimal? Okay, and what's your percent? Very good. Who had 20? What you got? Mm-hmm. Okay. I'm going to say 7 if that's okay. All right. What about 50? Who had 50? What you got? Well, tell me your fraction first, please. You're fine. You had 50? So if you had 50, it should be 63 over 80. That's okay. The reason it's 63 over 80 because this is 50 more made over 50 more attempted. Okay? So I'll give you just a second and you can tell me your decimal when you get it. Who had 100? We can fill in the fraction. What? Okay, if you have 100, okay, that's fine. You can fix it real quick. That's the best part of making mistakes. We fix them, right? And when we fix them, we learn. Okay? You got a decimal yet? 63 divided by 80. What'd you get? Yours would be 113, yes, over what? 100 more than what we started with. Very good. Do either one of you have decimals or percents yet? What'd you get? 0.788. Good. 78.8%. That's right. Okay. And what about your decimal and percent? 0.869. 86.9. Okay. You okay so far? So what if we had X consecutive free throws made? What would our fraction be? 13 plus X over 30 plus X, right? We're not multiplying by the free throws we made. We were adding them to the free throws we'd already made, right? Okay. So I've already graphed this. Okay. It looks a whole lot like that. Just so we have an idea. What equation relates these two quantities? Can we use this somehow to relate our two quantities? Isn't that part of our equation? To find the percentages? So y would be 13 plus x over 30 plus x, but that's not all, because it's asking for the percentage. What did we have to do to get to the percentage? Very good. Multiply it by 100. Okay? I'm going to ask a question. I'd like you to wait at least 3 seconds before you answer, so everybody in the room has a chance to think about it. Is that fair? After how many consecutive free throws will Charlie's percentage reach 80%? While you may not know an exact number right this second, do you know what it's between? How do you know that? How do you know what it's between? So on the chart it says 78 here and 86 here, so we know it's somewhere between what? 50 and 100. Okay? So I'm going to go in my calculator. Oh, where'd it go? Great. It's not here. Okay, home, new document. No, I don't want to save my old one. I just had it. I apologize for that. So I'm going to go ahead and put in my fraction. I'm going to put it in a parentheses. And I'm going to say 13 plus x over 30 plus x. And I'm going to multiply that by 100. What's the most common popular reaction right now? I did something wrong, right? Did we do something wrong? No, what's wrong with it? It's not zoomed right, okay? So, and in fact, it's not zoomed out enough, is it? Because I know I have to go to 100 on my x-axis and 100 on my y-axis, don't I? So I'm going to go to my Windows settings. I'm going to start at -1 so I can see my axis, except I didn't mean to push enter. Okay, stop. Menu, window, settings. So I went from -1 to 100, and I also here want -1 to 100. Okay? Now, this one starts way up here. Why did I start mine here? See this? You remember what this means when we're graphing? That means we're cutting that part out because nothing's happening there. So that's why I was able to start mine right there, because that's about where 40 is. You okay with that? Okay, so if I go to my table, Control T, that would be really nice to see, because then I can sit here with my thumb on the button, scrolling down, and what am I looking for in this column? 80. Whoa. There it is. After how many consecutive free throws did I get 80%? 55 free throws. When will the percentage read 90%? Scroll, scroll, scroll. Now I could set this equation equal to 90 and solve that, couldn't I? Okay. Oh, there it is. 140 free throws. Now 100%. You want to argue with me right now? Yes? Why? Why would you want to argue with me about this? Why? Why won't it ever reach 100? She already missed some, didn't she? She already missed 17 at the very beginning. It doesn't matter how long I sit here and scroll. Will it ever get to 100? No. Okay, so for the record, I agree with you. It won't. Technically speaking, it actually will. Because there's a certain point where the calculator can't handle that many decimals and it just rounds and it gets to 100. I'm just telling you, okay? Somebody sat here and did this a couple of years ago and just scrolled and scrolled and eventually said 100 because of the rounding effect, okay? I'm not going to sit here and keep pressing the button. We understand well enough that it's not going to get to 100, so when will it reach 100%? Never! She already missed some, okay? Often when using rational functions, when you plug in larger and larger numbers for x, the answers for y keep getting closer and closer to a certain value. This value is called a limit. For those of you who are going to take pre-cal next year and possibly even calculus the year after that, or even in college, this is a huge deal in calculus and pre-cal. Limits. Okay? It's when numbers are approaching another certain number. Okay? We are getting to the end of the period, and unless I hurry, we're not going to get a chance to finish. So can you guys trust me on a couple things right now? Okay, I'm going to fill in all these tables. I'll either let you fill in or just take a picture of them, and you can copy them later. Okay? It's up to you. Okay, so I need to start talking. So if you didn't write exactly the same speed as I did, I want you to take a picture and write this down later. Fair? Because here's what I need you to notice. As my x's are increasing, where is this value going? What is it getting closer and closer to? What is its limit? It's 1, right? What value is getting closer to 1? Why? Where's this one going? It's getting closer and closer to what? 1.6 repeating? Where's this one going? This one's not quite as easy to tell because it's got scientific notation. Can I just tell you? It's going to 0. As x is increasing, where's this one going? Also to 0, right? What about this one? As x is increasing, where's y going? What's it approaching? 0.5, right? Good. What about this one? Nowhere, is it? It's not approaching anything. It's just as x is getting giant, so is that. What about this one? As x is increasing, what is the limit of this number? Very good. 2.5. And what about this one? None. So here's what I need you to recognize without us having time to figure it out together. Okay? Look at the exponents here. Are they the same or different? They're the same. Look at these numbers right here. What's 1 divided by 1? 1. Are these exponents the same or different? They're the same. Look at these numbers right here. Isn't that what that is? Look at these exponents right here. Are they the same or different? They're the same. Look at that. Isn't 1 over 2.5? Look at these right here. Are these the same or different? The same. Look at that. When they're different, it means this. Look at this one. Are these the same or different? Different. Which one's bigger? The numerator. There's none. Look at these two. Are they the same or different? Different. Where's the bigger one? Numerator. There's none. But look at these two. Same or different? Different. Where's the bigger one? Bottom. It's 0. Y equals 0. This one's bigger. Y equals 0. Okay? I'm going to keep going. It'll be on the video that I upload here because I want to fill in this chart for you. This right here. And then these 4 problems right here on the back are homework. So you have 8 total problems. 4 on this page, 4 on the other page. That's right there. Bye. First, we want to look at the exponents. We want to figure out which one's the greatest in the numerator and the greatest in the denominator. In each, the greatest exponent is called the degree. We've talked about that before, but it's been a while. Okay? So first of all, if the degree of the numerator is greater, like we talked about right here, this degree is 2, this is 1, so the numerator is greater. This degree is 3, this degree is 2, so the numerator is greater. There is no horizontal asymptote. Okay? Second of all, if the degrees are the same, like this one, and this one, then we look at the leading coefficients, numerator and denominator. If the degrees are the same, we look at the coefficients. That's where we got 0.5. If the degrees are the same, we look at the coefficient. I had 1 divided by 1. That's where I got 1. Okay? So we take the leading coefficient of the numerator and divide it by the leading coefficient of the denominator. If the denominator is greater, like this one right here, like this one right here. See, this has a degree of 1, this has a degree of 2, so the degree of the denominator is greater. This has a degree of 0, and this has a degree of 1, so the degree of the denominator is greater. So y equals 0. Y equals 0. Okay? So follow this little flow chart here to help you with these 4 problems at the bottom.